Everybody get up, no need to cram now. We got a real jam going down, going down, going down, going down, going down, going down. Welcome to the IntelliJAMS.
Alex, what's going on, dude?
He's back. I feel like we've had a lot of guests on the pod, but the OG crew back together here.
Yeah, dude, I'm pumped. I know that the pod has continued and there have been a lot of good ones. In fact, probably better than ever, but I'm honored and happy to be back to the IntelliJAMS.
Selling himself short. Oh, no,
Not
they're
at all.
different. They're different.
But no, dude, I'm excited to be back. I know you want to jam on something. You have not told me what we're jamming on. What do you want to jam on today?
Okay, so I want to jam on something, but I also want to jam on it in a specific lens. So what I want to jam on today is statistical significance, but I want to jam on it more from a like layman's terms than like getting really nerdy or actually scientific about it. I feel like we get a lot of questions around like, hey, I'm going to run this or I'm going to do this. How long is that going to take to become statistically significant?
Yeah.
How long should I expect to wait? And like the answer is kind of it depends, but I want to jam a little bit more on like, why does it depend? What does this mean? What are we actually getting to?
Cool. I love this topic. And honestly, I am probably not the most qualified person, surprisingly, to talk about this. There are people on our team who work with data and build models that might even be more qualified. But I think I can, for the purposes of this pod, give a good enough rundown of statistical significance to the point where we have a good outcome.
So you're actually the person I want to talk to about this because I actually got pulled into a conversation on Twitter where it was talking about like the way that IntelliJAMS calculates statistical significance and the other different methods that are out there for calculating it. And it got like very scientific. Not what I want to cover today. Like we're probably going to say things that the data analyst is going to be like, whoa, you guys are wrong.
Yeah. I'm going to get canceled in the data scientist community.
If we do this right, that community is going to be pissed at us. I'm sorry, guys. I want to get to a conversation where someone who's maybe just like getting started with testing, experimenting, they haven't used the tool before, they're going to get into this for the first time and they know, hey, statistical significance is something that I should be striving for, but they don't necessarily know like why or what it is or how long it will take.
Okay. So let's start with this concept of statistical significance. And I might even reframe the way we want to think about it is around confidence. But like the origins of statistical significance, like when you first start learning about statistical significance, or at least when I did in school, was around like science and experimentation. Like you run a biology experiment and there's like, remember p-value of less than 0.05. And that's like sort of the original is like statistical significance. It was this very like, I would say there was like a generally accepted 0.05 threshold of confidence in order to achieve statistical significance. And if you were, below that threshold, or in this case, like below that threshold of confidence, so above that p-value, then you were like, it was not statistically significant. So statistical significance was very binary. It either wasn't or it was. And over time, as statistics gets applied to more and more domains, the way we think about it has changed. And I would argue that like to think about things in a binary form, like it is or it is not statistically significant, is probably not the right way of thinking about it in experimentation, but more about framing it in the context of confidence. And confidence is a spectrum, and how confident are we? And so, let's talk about confidence. And I think we can go from there. But hopefully that makes sense. I don't know if that was like even the best history lesson. I'm coming in kind of blind here, but
no, it's good. Like TLDR, when something becomes stats, like it's either stat sig or it's not. It's binary. It's yes or no. And like generally speaking, the historic application of this was in stats to try to prove or disprove a hypothesis. Being certain about something, to your point, is important when it's life or death. But when we are taking this into different domains, such as business, very rarely are we in a life or death situation. So the being confident over certain is a little bit better of an application for us in the business world. And I think that leads us into like something that we do in IntelliJAMS is like, hey, probability to beat control, probability to be the best of like these variants, trying to find ways where it's not as binary of like yes or no, and start to give a little bit more insight into like, is this better?
Yeah, and exactly. I think that when we think about, A/B testing your site, so one of the questions you asked before, let's now talk about a little bit like why does it depend? So like it depends is a very common question that we get when we ever ask about confidence and statistical significance. One of the main thing it depends on, I guess it depends on two things. One is how much data, and that's like the obvious thing that everyone knows is like the more data you have, the more confident we can become. The second thing it depends on is like how big of a delta, the like term here is effect, right? Like how big is the effect of the treatment? So we change the price, we measure difference in conversion. How big is that effect? We change a landing page, we see a difference in add to cart rate. How big is that effect? And the bigger the effect, the more confident we can be that the effect is different. And by the way, like one of the things too that when looking at statistical significance, again, in a traditional sense, is what you're trying to understand, again, traditionally, like a t-test, for example, which is often used in medicine, is like, are these two groups different or are they the same? Like, and so it's not even so much about the magnitude of the difference, it's about just the fact that they are different. And so add to cart rate is higher in group B. The treatment has led to a higher add to cart rate. You may have statistical significance. That may be true. The effect may not be very large, right? Like it may almost be unimportant for the purposes of what you're trying to achieve. So like to say, like going back to this concept of like statistical significance being binary and saying, is it statistically significant? Also, like I think doesn't necessarily do justice to the concept of, well, what I'm trying to do is make more money. So if like I'm making $2 more and I can feel statistically significant confidence about that, that doesn't really like make me happy. And so I think like one thing that we try and do too is help create not just measures around confidence, but also measures around magnitude and like how big the effect is. Does that make sense?
Yeah. And like, so I was having a personal jam with someone on the team about like, hey, how do we talk about how long something's going to take to reach this? And we were hitting on exactly those two things. It's like, how much data do I have? Which is what everyone tends to gravitate towards, right? It's like, oh, I will get to, I'm going to try to use the word confident for the rest of this podcast rather than static. It's like, how do I get to a point of confidence in this? And it's, oh, well, it depends how many orders you get. Like if you're going to run a price test, like how many orders are coming through here? But it's not just that. It's the second part. And I think that's the most overlooked one is like, how drastic is the change you're making? Because a more drastic change is going to be picked up in a smaller sample than just having like throwing as much data at it to try to get to that point quickly.
Mm-hmm.
So like, hey, if I'm going to run a price test, like if I run a 2% price change, that's going to take a lot more people coming through for us to be confident that there is a winner here and it's not just random or it's not just locked in a tie. But if I go and make a 20% price change, that's a pretty big change that I'm probably going to get to confident and see that a lot faster. So one thing I want people listening to this to like take away is, yes, more data is better. A bigger data set is going to give you more accurate information, a better call, but a big change or like testing something, taking a bigger swing, testing something that is going to have a bigger effect or impact is also going to let you get results faster. Now, I'm not saying you do that and just be like, yep, this is it. But like that might help you triangulate and get to a better spot where you can get a little bit more fine faster.
Yeah. Another way to think about it, and this might be like probably the best way, and one of the things we try and represent in the dashboard is like around every measurement, we have a confidence interval. So with more data, that confidence interval shrinks. And with a measurement, and you have two groups, so let's say you're measuring the conversion, and you have group A and you have group B, so you measure the conversion rate at each group, you have a confidence interval around that. and then that might start to shrink. And so when we talk about the size of the effect and not being confident, what we're saying is that you could have a really, really narrow confidence interval, but if the difference between group A and group B is really small, no matter how small you get that confidence interval, if the effect size is even smaller, well, you actually don't know which is the winner, group A or group B. But you can be really confident actually in the results that group A and group B will perform the way that we are measuring it, because we have a lot of data to suggest that the measurement is good. And so actually, like, we can't be very confident that group B is better than A or that group A is better than B, but we can be confident that the measurement is really good. And so again, like maybe an inverse of that scenario is that you have a big effect, group A and group B, with really wide confidence intervals. And so it may be the case that we are confident group B is better than group A, and it is statistically significant, but like the confidence intervals are so wide, and yeah, they're not overlapping, but they're like almost overlapping. And you can see that like, well, actually it's possible that like we are understating group A's results and we are overstating group B's results because, you know, people are random and there's noise, and we're dealing with imperfect, testing conditions. And so therefore, like, you may have confidence that they're different, but like you might not necessarily be very confident in the magnitude of that change. And so I think that, like, you know, it always depends on what the goal function is. It depends on what the metric that we're like aiming for is. And then I think also like being able to understand, okay, I'm okay with maybe the worst case scenario of, or the 80% worst case scenario here. And you look at the confidence interval and you say, okay, like the left or close to the left side of that interval, I'm still comfortable with that. Then that's like a good place to move forward. Whereas like, you know, that's where you can sort of make a call. Does that make sense?
Yeah, exactly. Let me say it back and see if I got it. Like, when you can be certain that a variant beat a control, but if the interval is like basically like the spread is really large, we're very confident that this is the better situation. How much better, we still don't know. There is a wide range of potential possibilities inside of here. And I think, again, this comes back to like applying this to different domains. And like the business scenario is like, whether A or B wins is important, but what's more important for like most of the people who are testing with IntelliJAMS is like better by how much. Like, if I go and do said thing, what can I expect? If I was running this with like 10% of my traffic, like what could I expect if I was to open this up to 100%? Or what could I expect if I was to implement this for everyone or a specific segment? Like, knowing how much is what gets you kind of like the green light to continue forward with some of these projects, not just like, hey, this is better, like this is a winner and this is a loser.
Yeah, exactly. So to summarize, I think that looking at confidence intervals is probably your best approach here, and then trying to understand, hey, knowing that the outcome may be anywhere in this confidence interval and it's distributed, so it's not like it's more likely that it's around, that it is close to what we are measuring. Yeah, close to the middle. And then like it's generally, and this is like a little nuanced, but it is generally symmetrical, and not perfectly, and not for every measurement, but it is generally symmetrical, where it can be like higher, it could be lower. And you have to start asking yourself, well, like in a maybe like less optimistic scenario, am I still comfortable with it? And again, depends on what you're testing, but sometimes when you test something, and if you have really, really narrow confidence bands, and you might not know that like B is better than A or A is better than B, but you like B more, and you know that it's, no matter what, the worst case scenario, it's not more than 0.5% worse than A. And in the best case scenario, it's 0.5% better, or 2 or 1% better, right? Like, so you don't know if it's really better or worse. There's an optimistic case that it's better. The most pessimistic case is that it's only a little bit worse. And so then you can go forward with that option, even though it hasn't like technically reached statistical significance.
I like this. This has been good. Like, so we basically hit what is it, why care, the whole last like 5 minutes of this, and how long is going to depend. But again, more data, bigger change. That's going to help here. Last question before we wrap this jam. In terms of like, there's kind of like two camps that I see. So, hey, again, we said at the beginning, we might get canceled by like the data scientists here. It's like, I need to wait till I'm like at least 95 to like 98% confident in something to pull the trigger on that change. There's also a brand that I work with. I'm not going to name them, but they fly a lot more loose and wild on these things where it's like, oh, I'm at 70% and like I've seen enough that I'm willing to go try this. Like what, like, how do I want to word this? What's the trade-off in there? Is there any? Like, is one of these guys right? One of these guys wrong?
I think that we've talked about the art and science of testing, and this to me is where your own intuition is really important. If you are making really high stakes decisions, maybe we call them also in our business one-way doors, where I am making a change that I can't undo, then it might be worth having a higher degree of confidence and getting more data. But I generally, like, as a founder and I run a business and we shoot from the hip all the time, there is so many decisions that we make where we have imperfect data. And as founders and operators and people who listen to this podcast, I'm sure you guys make decisions all the time with imperfect data. And so then the question is what are the stakes and how much do we care? And the trade-off is time. And it takes more time to get to a higher degree of confidence because you need more data. And so if you can operate more quickly and have the data support your intuition, I think then that's a really good way to move forward and not necessarily lose out on the time aspect of the trade-off here. And also recognize that almost all the decisions that we make in business are two-way doors. And it might feel like changing your prices is a huge one-way door that I can never walk through. But in reality, you can change your prices and then change them back. And, and most of the times what we are doing as operators in business are two-way doors.
I love that answer. And even like, hey, what's at stake here is time. One thing I'll add into this is like time for like how long that experiment runs, but also don't forget the opportunity cost of like getting to the next thing. So like calling a winner and being able to move into the next experiment. Like one thing I love to talk about is like the most dangerous thing for any of us is just to stand still for too long, like get complacent. So, hey, if that's going to take, the analogy I always use is like, hey, back in school, if I had to put 10 hours into getting an A and I had to put 45 hours into getting an A plus, is the A plus worth it? To some people it is, depending on like what the importance of that grade is. Maybe, but like that's a lot of extra time to get to a little bit extra on that report card or on that project.
Yeah. And the statistics are similar. Like it's not linear. You can get 80% of the way there very quickly, and the last 10 or 20% might take a lot longer than the first 80. So statistics are also not linear, and every incremental percent gets harder and harder and harder to achieve.
All right, I think we got what we needed on the statistical significance front. Again, we're not going to say that this was a scientific chat about this, but trying to give people a good understanding of like what is it, why care, how long,